Hello science fans and welcome to SHE-ensya. Where did ice cream come from? What are the important components that make ice cream so delicious? Why is ice cream so smooth and not hard or filled with ice crystals despite being frozen? And why is ice cream so yummy? Why do we ask questions? The SHE-ensya Why series will dissect some of our most head-scratching who, what, where, when, and why questions, piecing out the scientific principles from historical records, conspiracy theories, and mass media. Join us in today's episode where we ask the question, why ice cream? There is perhaps no fonder childhood memory than the local sorbetero passing through the neighborhood, his clanging bell ringing clear in the sweltering heat of the afternoon. But ice cream isn't just for kids. Filipinos consume more than 21 million gallons of ice cream per year, and that's about 0.2 gallons per person. Now, the ice cream we all enjoy is the result of years of experimentation, involving, you guessed it, chemistry. But wait, where did ice cream come from anyway? Well, an ice cream-like food was first eaten in China in around 618 to 97 AD. King Tang of Shan had 94 ice men who helped to make a dish of buffalo milk, flour, and camphor. A kind of ice cream was also invented in China at around 200 BC, when a mixture of milk and rice was frozen when it was accidentally packed into snow. Roman emperors are also supposed to have sent slaves to mountaintops to bring back fresh snow, which was then flavored and served as an early form of ice cream. And the King of England, Charles I, allegedly offered his chef 500 pounds a year in order to keep his ice cream recipe a secret. But as for ice cream sundaes as we know it, they were invented when it became illegal to sell ice cream sodas on a Sunday in the American town of Evanston during the late 19th century. To get around the problem, they replaced the soda with syrup and called the dessert the ice cream sundae. Some of them actually replaced the Y with an E to avoid conflicts with local religious leaders. But what makes ice cream ice cream? What are the general ingredients found in this delicious dessert? Well, if you've ever made ice cream or have visited an ice cream factory, you might be familiar with its general ingredients: milk, cream, and sugar. But there's one component that you might not be so familiar with, perhaps because you literally can't see it, and it's air. But why is air so important in the making of ice cream? Well, if you ever had a bowl of ice cream melt, and then you refroze it and ate it later, you might have noticed that it doesn't taste as good. You might have noticed also that if you set a whole container of ice cream on the table and let it melt, the volume of the ice cream would go down. And this is because air makes up anywhere between 30 to 50% of the total volume of ice cream. And this is important because the structure of a substance can have a big effect on how it tastes, and that the structure often controls the rate at which flavor molecules are released in the mouth. And the larger the structure of the molecules, even in the case of ice cream, the longer it takes for the flavor molecules to be released. The larger the amount of air added, which is known as overrun, then the larger the structure of the ice cream would be. So for example, if the volume of ice cream is doubled by adding air, then the overrun is considered to be 100%, which is the maximum allowable overrun of any kind of commercial ice cream brand. The less expensive ice cream brands usually have higher amounts of air, and the consequence of this would cause the ice cream to melt a lot faster. Apart from affecting the release of the flavor, the amount of air also has a huge effect on the density of ice cream. A gallon of ice cream must weigh at least 4.5 pounds, making the minimum density 0.54 grams per milliliter. Higher quality brands actually have higher densities, up to 0.9 grams per milliliter. So the next time you go to the supermarket, compare different brands with each other. The heavier the ice cream is, the better quality it is.
Oh, whoa, whoa, whoa! Whoa!
As chemical materials go, ice cream is actually an emulsion, a combination of two liquids that don't normally mix together. In ice cream, liquid particles of fat, called fat globules, are spread throughout a mixture of water, sugar, and ice, along with air bubbles. So if you examine ice cream closely, you can see that its structure is porous. A typical air pocket in ice cream will be about 1/10 of a millimeter across. But the presence of air also makes ice cream a type of foam. Other kinds of foam foods would be marshmallows and whipped cream. But going back to the fact that ice cream is an emulsion, you can actually expect that the fat droplets that are present in the mixture would separate after some time. The same issue is experienced by milk, but in the case of milk, each fat droplet is covered by milk proteins that minimize their interaction with each other. These milk proteins act as emulsifiers, substances that stabilize emulsions and allow the liquid droplets present in the emulsion to remain dispersed instead of clumping together. Milk proteins have what we call a nonpolar site, a portion that doesn't like water. And since in chemistry, like dissolves like, these nonpolar portions group together and are attracted to the fat globules. So this is good for milk, but not so good for ice cream, because we want some of the fat globules in ice cream to actually group together a little bit to trap some air. So another emulsifier is added to allow the fat droplets to partially group together. This emulsifier replaces milk proteins on the surface of the fat droplets, leading to a thinner membrane which is more likely to coalesce or group together during whipping. A common emulsifier is lecithin, which is commonly found in egg yolks. Lecithin is actually a generic term used to refer to molecules containing long strands of fatty acids linked to glycerol together with choline and phosphate. Lecithin inserts itself between the fat globules, which helps the fat globules to clump together, and as a result, the air bubbles that are present in the mix are trapped by this partially grouped together fat. This adds that delightful firmness and texture to the ice cream, allowing it to hold its shape. Now, closely related to emulsifiers are stabilizers, which make the texture creamy. Stabilizers have two roles. The first is they prevent large crystal formation. This means that smaller crystals form that are easier to disperse, which means they melt more slowly than larger crystals. Second, stabilizers act like a sponge by absorbing and then locking into place any liquid in the ice cream. So without these emulsifiers and stabilizers, ice cream would end up looking more like a milkshake. And so, science has spoken. Ancient records of ice cream are available, but the current version probably came to be because it became illegal to sell ice cream sodas sometime during the late 19th century. Air is one of the most important components of ice cream because air molecules change the structure of the ice cream, causing it to release its flavor a little slower. The more air there is in ice cream, the lesser quality it is. So please make sure to check the density of the ice cream before buying at the supermarket. Ice cream has multiple types of emulsifiers and stabilizers that keep it creamy and also cause it to melt a little slower. And they do this by preventing large crystal formation. But given all of this, why is ice cream so yummy? What makes ice cream so yummy is in the interplay of ingredients. A big reason why ice cream tastes so good is because of its high fat content. Ice cream must contain at least 10% fat, and this usually comes from milk. High-quality ice cream can have up to as much as 20% fat content, which gives it its rich, velvety texture. Another key factor is sugar, and the fact that cold tends to numb the taste buds, making them less sensitive and complicates ice cream production. So even more sugar is added in order to create the desired effect at the low temperatures at which ice cream is served. So you'll notice that if you taste ice cream at room temperature, it will taste overly sweet. And so it is this dangerous combination of fat and sugar that often gives us a sugar rush akin to an energy boost that makes ice cream so deliciously addicting. And with that, we end our video for today. I hope you were able to learn something from it, and if you did, I hope you can give it a thumbs up and also subscribe to our channel. If you have any comments, questions, or suggestions, please don't hesitate to message me, your resident Filipina scientist, in the comments section below. Thank you very much, and see you around!